Hello students, welcome to our science class. I'm your science teacher, Ma'am Crusha M. Luisman. For today's lesson, we will be discussing about acceleration. At the end of today's lesson, you should be able to describe the motion of an object in which velocity changes in either magnitude or direction or both. Before we proceed, we will have a simple review on speed and velocity. The first column of the table shows the measurements, and in the second column, you are going to determine the following quantities, whether it is speed or velocity. I'll give you 1 minute to answer. Okay, if you are done, let us try to answer each item. For item number 1, 2 miles per hour, the answer is speed. Number 2, 15 meters per hour, the answer is still speed. 3, 3 miles per hour east, the answer is velocity. 4, 10 kilometers per hour west, the answer is velocity. 5, 15 meters per second north, the answer is velocity. So speed is simply how fast you are traveling, while velocity is speed in a given direction. Vehicles rarely move at constant speed, but oftentimes they change speed. Consider the figure below. The figure shows the reading of a car at 1 second interval within 4 seconds. Initially, the car was at rest. The car started to move. After a second, the speed was 5 km per hour. At 2 seconds, the car's speedometer reading was 15 km per hour. Another second later, the car's speed reached 30 km per hour. Finally, at 4 seconds, the speed was 50 km per hour. The changing motion of the car can be described in terms of acceleration. Acceleration is defined as the rate of change in velocity. In equation, acceleration equals to change in velocity divided by change in time. Change in velocity is the difference between the final velocity and the initial velocity. Change in time is the difference between the final time and the initial time. Let's have a sample problem under acceleration. As a car comes to a stop, it slows from 25 meters per second in 2.8 seconds. Find the acceleration of the car. What are we looking for? We are looking for the acceleration. Based on the problem, the initial velocity is given, which is 25 meters per second, and the final velocity is 0 meters per second because the car came to a stop. The time is also given, which is 2.8 seconds. Then we use the formula for acceleration. A is equal to Vf minus vi over t. We simply substitute the values. A is equal to 0 meter per second minus 25 meter per second over 2.8 seconds. What is 0 minus 25? We have negative 25 meter per second divided 2.8 seconds. Then we cancel the common units to eliminate seconds and divide. We finally have the acceleration negative 8.93 meter per second squared. Why negative sign? The negative sign indicates that the car slowed down or decreased its speed, showing a negative acceleration. Using the average acceleration formula, you can determine for the other quantities like time, initial, and final velocities as follows. Equation 1. A is equal to final velocity minus initial velocity over change of time. Equation 2. Time is equal to final velocity minus initial velocity over acceleration. Equation 3. Final velocity is equal to initial velocity plus acceleration multiplied by change of time. Equation number 4. Initial velocity is equal to final velocity minus acceleration multiplied by change of time. It's quiz time! We will be answering 2 problems to check your understanding on our today's topic about acceleration. Pause the video while you are answering and press play if you are done, so you may not pause the video for a while. Time's up! Let's answer number 1. A car travels at 90.0 km per hour. What is its acceleration in 3.0 r if it is started from rest? We are looking for acceleration. From the problem, we can see that the given values are the initial velocity, which is 0 km per hour, and 90 km per hour, which is the final velocity, and time, which is 3.0 hours. To find the acceleration, we just use the formula A is equal to Vf minus Vi over t. Then, we substitute the values. A is equal to 90 km per hour minus 0 km per hour over 3.0 hours. What is 90 minus 0? We have 90 km per hour, then we divide to 3.0 hours. And we have the acceleration 30 km per hour squared. Number 2. How long will it take a driver to bring a jeepney traveling 50.0 meter per second to a complete stop if its acceleration is negative 0.500 meter per second squared? In the problem, we are looking for how long will it take or the time given values are 50.0 meter per second, which is the initial velocity, 0 meter per second, which is the final velocity. The acceleration is also given, which is negative 0.500 meter per second squared. First, we need to know the formula. To find the acceleration, it is A is equal to Vf minus Vi over t. To find the time, we derive the formula from the acceleration. Upon deriving, we have now the formula for time. T is equal to Vf minus Vi over A. Then, we substitute the values. T is equal to 0 meter per second minus 50 meter per second over negative 0.500 meter per second squared. Then, we cancel out the common unit and we are left with the time, which is 100 seconds. Let's have a quick recap. In this video, we have learned that acceleration is equal to rate of change in velocity over time. We can determine for the other quantities like time, initial and final velocities as follows. Equation 1, A is equal to Vf minus Vi over T. Equation number 2, T is equal to Vf minus Vi over A. Equation 3, Vf is equal to Vi plus acceleration. Equation 3, Vf is equal to Vi plus acceleration multiplied by change of time. Equation 4, Vi is equal to Vf minus acceleration multiplied by change of time. This is Ma'am Crescia Luisma once again, your teacher in Science 7, leaving you with my favorite line, changes are inevitable. We can't control it, but with God's guidance and hard work, a nice future awaits. Goodbye, everyone!